We're in section 7-3. And all I'm going to do is work problems. So we're going to start with problem number 4. We have e to the minus t over 2, and we have cosine 2 t minus pi over 1 over 8 pi. Okay, we want the Laplace transform of that, and we see that we can't really do that easily. So we're going to go and take e to the minus t over 2, and we're going to call this cosine 2t minus pi over 4. And then we're going to reach back into our trig days and say the cosine of a minus b is cosine cosine plus sine sine. So this is going to be e to the minus t over 2, cosine 2t cosine pi over 4, plus sine 2t sine pi over 4. And seeing that pi over 4 is 45 degrees, that's going to be square root of 2 over 2. So we're going to have square root of 2 over 2, that's really bad, e to the minus t over 2 cosine 2t plus square root of 2 over 2 e to the minus t over 2 sine 2t. Okay, so that's what we have. If we look at number 11 and number 9 on our inverse, on our Laplace transform table, we're going to see that if I take the Laplace transform of this, I'm going to get square root 2 over 2, and I'm going to get s plus 1/2 divided by s plus 1/2 squared plus 4 plus square root 2 over 2, 2 over s plus 1/2 squared plus 4. And now all we need to do is manipulate that sum and see what we can do with it. I've got, we'll put the 2 on the bottom, and I've got square root of 2s plus square root of 2 over 2 plus the square root of 2. And on the bottom, I've got 2s plus 1/2 squared plus 4. Okay, so that looks pretty good. We're going to go and multiply the bottom guy out, and we're going to take the square root of 2 out of the top guy. So I've got square root of 2 times s plus 1/2 plus 1 on the top, and on the bottom I've got 2s squared plus s plus 1/4 plus 4. Okay. Okay, what I'm going to do is I'm going to multiply top and bottom by 2. 2 over 2. Okay, when I do that, I'm going to get square root of 2, 2s plus 1 plus 1 more square root 2s plus 1 plus 2 for 3. Yeah, maybe we better, this is 2, the square root of 2. 2, the square root of 2 there. That makes this a 2 here. And that makes this a 1 plus 4 on top. Much better. On the 4 I have, the bottom I have 4s squared plus 2s plus 4 times 4 is 16 plus 1 is 17. Okay, so I've got the square root of 2, 2s plus 5 on the top, and I have 4s squared plus 2s plus 17 on the bottom, and that checks with back of book, which makes us extremely lucky, I think. Okay, number 6. F of s minus 1, s plus 1 cubed, and what I want to do is find the inverse Laplace transform. Okay, so f of s is going to be a over s plus 1 plus b over s plus 1 squared plus c over s plus 1 cubed. That's going to be my partial fraction that I'm solving. Okay, and I find I get my common denominator, which is the s plus 1 cubed, and I find my numerator is going to be a s squared plus 2 as plus a plus b s plus b plus c. And that's going to equal s minus 1 over s plus 1, the quantity cubed. Okay, so I look at the s squared term, and I see that a is the s squared term, and it is 0. So a is 0. I look at the s term, and I say I have 2a plus b, and that has to be 1. Well, if a is 0, then that implies b has to be 1. And I look at my unit term, and I see that a, which is 0, plus b, which is 0, plus c, which I don't know what it is, has to be minus 1, which clearly implies c is equal to minus 1. No, it doesn't. B is 1. Well, if B is 1 and 0 plus 1 minus something, so C has to be minus 2. Okay, much better. So my f of s becomes 1 over s plus 1 squared minus 2 over s plus 1 cubed. Okay, well that seems reasonable. We look at number 15 and number 16 of my Laplace transform table. We take the inverse Laplace transform of the whole thing. We get f of t is equal to t e to the minus t minus 2 t squared e to the minus t over 2. And so obviously those 2's can go away. So f of t is going to be t e to the minus t squared e to the minus t. That's a t. And we can take t e to the minus t out, and we're going to have 1 minus t, and that checks with the back of book. Authors managed to get 2 in a row correct. Totally awesome. Okay, now we're going to go to number 8. F of s plus 2 over s squared plus 4s plus 5. And we look at that a little bit and we say, well, if we completed the square on this guy, complete the square, and I hope you guys remembered how to do that from high school. We're going to end up with f of s is equal to s plus 2 divided by s plus 2 squared plus 1. And we look at number 11 in the Laplace Transform table. We take the inverse Laplace Transform and we end up with f of t is equal to e to the minus 2t cosine t, which checks at the back of the book, so that's a good thing. Number 10, we have 2s minus 3 over 9 s squared minus 12s plus 20. Very interesting. Well, I don't like the 9 in front of the s squared, so I'm going to divide everything by 9. 2 over 9s minus 3 divided by s squared minus 4 over 3s plus 20 over 9. Way to go. Right at 9. Okay, 9. So that seems reasonable. We're going to do a complete the square again. Complete the square. And now what are we going to have? We're going to have 2 over 9s minus 3 divided by s minus 2 over 3 squared minus 4 over 9 plus 20 over 9. Okay, I'm going to multiply top and bottom by 9. And I'm going to have what is going on here? Why is that a 3? This should be a 1/3. And this should be a 1/3. Okay, so I'm multiplying by 9. And I get 2s minus 9 over 3, which is 3. And on the bottom, I get a 9. And I've got s minus 2 over 3 squared plus 16 over 9 times that 9. And what do I want to do with that? Well, I have s minus 3 over 2. So I'd sort of like to have s minus 3 over 2 in things. Okay, because I'm looking at number 11 and I see that I'm getting close. So I'm going to rewrite this as s minus 2 over 3 plus s minus 2 over 3 minus 5 over 3, because I have an s minus 2 over 3 on the bottom. So I'm going to take out this 3. I'm going to turn into, does that make it a minus 3? Yes, it does. So 2 and 2 is 4, 5 is 9, divided by 3 gives me that 3. Okay, and on the bottom, I have 9 s minus 2 over 3 squared plus 16 over 9. Okay, that's nice. Now I'm going to divide this guy up some. So I've got 1 over 9. I've got s minus 2 over 3 divided by s minus 2 over 3 squared plus 16 over 9. And then I've got plus 1 over 9, s minus 2 over 3 divided by s minus 2 over 3 squared plus 16 over 9. And then I've got a minus 5 over 3. Now, what is it that we want on top? Okay, so number 9, look at number 9, and I have a k squared on the bottom, I want a k on the top. So what I want on the top is a 4/3. So I want a 4/3 on the top. I currently have a 5/3 that's sitting there. So I'm going to bring it out. I'm going to multiply it by 3 over 4 so that everything works out. And then I'm going to have s minus 2 over 3 quantity squared plus 16 over 9. Okay, so that's what I've got. And then I say, well, I can use number 11 on that guy, I can use number 11 on this guy, and I can use number 9 on that guy. And I'm going to take the inverse Laplace transform of all that I see. And I'm going to have 1/9 e to the 3t. No, 2 over 3t. 2 over 3 e to the 2 over 3t cosine number 11. Okay, what is my k is going to be 4 over 3. Okay, so it's going to be 4 over 3t. 4 over 3t. And then I'm going to have a 1/9 e to the 2 over 3t cosine 4/3 t. And then I'm going to have a minus 5 over, there's a 9 sitting right here that we forgot to write down. It's a 9 sitting right there. 5 over 36 e to the minus 2 over 3t sine 4 over 3t. Okay, so these are the same guy. I'm going to take out e. I'm going to take e 2 over 3t over 9 out of the whole thing. And I'm going to have 2 cosine 4 over 3t minus 5 over 4 sine 4 over 3t, which checks with the back of the book. That doesn't necessarily mean too much. The author has been wrong in the past. Okay, we're going to go with number 12. We have f of s is 5s minus 6 over s squared minus 3s. And we can rewrite that as 5s minus 6 divided by s minus 3. We can look at the partial fraction, which is going to be a over s plus b over s minus 3. And we see that the numerator is going to be going to be as minus 3a. As minus 3a plus bs. And that's got to equal to 5s minus 6. If that were an s, it would be 5s minus 6. And this is over s minus 3. That's over s minus 3. I look at the s term, and I see that a plus b has to be 5. And I look at the unit term, and I see that minus 3a has to be minus 6, implying that a is going to be 2. Well, if a is 2, then b has to be 3 in order to be a plus b is 5. So I've got f of s is equal to 2 over s plus 3 over s minus 3. That's number 4. This is number 7. I take the inverse Laplace transform, and I get f of t is equal to 2 plus 3e to the 3t. And that checks with the back of the book, and we're happy about that. Now we're moving on to 14. Now why am I doing so many of these? Well, because you need to do that many too. You have to get familiar with what's going on here. 5s minus 4, s squared minus s cubed. S cubed minus s squared minus 2s. Okay. So I've got 5s minus 4 divided by s squared minus s minus 2. I've got 5s minus 4. I've got s minus 2, s plus 1. Okay, so now I'm factored, and I find if I do a partial fraction, I'm going to have a over s plus b over s minus 2 plus c over s plus 1. And so 5s minus 4 divided by s over s minus 2, s minus s plus 1 has to equal as squared minus as minus 2a plus bs squared plus bs plus cs squared minus 2cs, all divided by s minus 2, s minus s plus 1. And it'd be a good idea if the c was just a little bit nicer. Okay, that's just a little bit nicer. Okay, I look at my s squared term. I find that a plus b plus c is equal to 0. I look at my a plus b plus c has to be 0. I look at my s term, minus a plus b minus 2c has to be 5. That 5 sitting there. I look at the unit term, minus 2a has to be minus 4. This implies that A is equal to 2. All right, well, if A is equal to 2, then B plus C has to be minus 2, and B minus 2C has to be 7. Okay, now we break out Cramer's rule again, and we say that B is equal to minus 2, 7, 1, minus 2, and on the bottom we have 1, 1, 1, minus 2. Okay, so on the bottom we have minus 3, and on the top I have 4 minus 7, which is another minus 3. So B is going to be a 1. Well, if B is a 1 and A is a 2, then C has to be a minus 3. I have no choice in that. And now I find that my f of s is going to be 2 over s plus 1 over s minus 2 minus 3 over s plus 1. And I'm going to use number 4 and number 7 and number 7 and do an inverse Laplace transform. And I'm going to get f of t is equal to 2 plus e to the 2t minus 3e to the minus t, which checks with the back of the book. Okay, now we're going to do number 16. Okay, so I've got f of s 1 over s squared plus s minus 6, the quantity squared. Okay, that can be 1 over s plus 3, s minus 2, the quantity squared. Okay. All right, so we're going to have, we'll do a partial fraction. Move this back a little bit. I have a over s plus 3 squared plus b over s plus 3 plus c over s minus 2 squared plus d over s minus 2. And I'm doing that slightly different than I've done it before, but that's okay. We can do that probably. And now I figure out that on the top I have a 1 for my numerator. On the bottom I'm going to have a s squared minus 4as minus 4a plus b s cubed minus b s squared minus 8bs plus 12b plus c s squared plus 6cs plus 9c plus ds cubed plus 4ds squared minus 3ds minus 18d. Okay, now assuming that I did that right and I haven't made an error yet, I can continue the problem, and if I messed it up, we'll figure that out later. Okay, so I look at the s cubed term, and I see that b plus d is equal to 0. So that b plus d is equal to 0. I look at the s squared term, and I see that a minus b plus c plus 4d has to be 0. I look at the s term. I see that minus 4a plus 8b plus 6c minus 3d is equal to 0. I look at the unit term, and I have 4a plus 12b plus 9c minus 18d is equal to 1. And I have 4 equations for unknowns. Now, the problem is my TI 36, which I use, can only do 3 equations, 3 unknowns. And I have 4 equations, 4 unknowns. The good news is that we gave you a spreadsheet, I don't know if you noticed it or not, that solves 4 equations, 4 unknowns. Did you notice that anytime soon? So if I put this into my spreadsheet, it's going to tell me what the answers are. I wonder if I did that already. Let me check. Oh, look at that. I did it already. B plus D is 0. A minus B plus C plus 1, 4D is 0. Minus 4 minus 8, 6 minus 3 is 0. 4, 12, 9 minus 18D is 1. So I have 0.04, 0.016, 0.014, and minus 0.016. And those are easily remembered when we go back to our other thing, I hope. And what do we know about 0.04? Well, that's going to be 1 over 25. And 0.016 is going to be 1 over 2 over 125. Okay, so we're going to remember that. So we come back and we say f of s is going to be a, which is 1 over 25, 1 over s plus 3 squared, plus 2 over 125, which is b, 1 over s plus 3. Then it's going to be 1 over 25 again, 1 over s minus 2 squared. Then it's going to be minus 2 over 125, 1 over s minus 2. Okay. And now we look at number 15. And we look at number 7. And we look at number 15. And we look at number 7. And we take the inverse Laplace transform of everything we have there. And what do we get? We get f of t equals 1 over 25 t e to the minus 3t. We get plus 2 over 125 e to the minus 3t. We get plus 1 over 25 t e to the 2t. And we get minus 2 over 125 e to the 2t. And if we play with that just a little bit, we might be able to get what the back of the book has. And if we can't, then what good are we? F of t, 1 over 25. And I got a t, I have e to the minus 3t. I've got a plus 2 over 5, e to the minus 3t. I've got a plus t, e to the 2t. Got a minus 2 over 5, e to the 2t. And combine some of the terms a little bit with the t's and not the t's. 1 over 25, and I've got a t, e to the minus 3t, plus e to the 2t. And then I've got plus 2 over 5, e to the minus 3t minus e to the 2t, brackets, boom, boom, and that's what the back of the book has, back of book. So we were extremely lucky that we didn't mess up a 4x4 guy. Okay, next problem is number 18. F of s cubed. Guess it's s cubed. S cubed divided by s minus 4 to the 4th. Oh, that doesn't look good. Okay, so we're going to have a s minus 4 plus b s minus 4 squared plus c s minus 4 cubed plus d s minus 4 to the 4th. Isn't that just lovely? And then my numerator is going to be s cubed is equal to a s cubed minus 12 a s squared plus 48 as minus 64a plus b s squared minus 8bs plus 16b plus cs minus 4c plus d. At least the last guys are relatively easy to get. Okay, I look at the s cubed term, and I see that that is an a, and that a has to be a 1, so a is going to be a 1. Okay, I look at the s squared term. That's good because now I have 3 equations, 3 unknowns, so I ought to be able to solve this very easily. So a is 1. The s squared term, I'm going to have minus 12 because a is a 1, and then I'm going to have a b, and that's all I get, and that has to be 0, so that means that b is equal to 12, which means now I only have 2 equations, 2 unknowns. I'm ecstatic about that. The c term, the s term, 48a, which is 1, minus the s term, 8b, which is 12, 96, plus c has to be 0, which implies that c has to be 48. And then I look at the unit term. Now I have 1 equation, 1 unknown left, so that should be pretty good, except I can't see the problem now. Okay, so the unit term, I have minus 64. I have 16b, 16 times 12, 192, minus 48 times 4, 192, plus d has to be 0, so d has to be 64, and isn't that lovely? So my f of s is going to be 1 over s minus 4 plus 12 over s minus 4, the quantity squared, plus 48 over s minus 4, the quantity cubed, plus 64 s minus 4, quantity to the 4th. Okay, and I see that number 7 works on him, number 15 will work on him, number 16 will work on both of those. I have to be smart about it. Inverse Laplace Transform. F of t is equal to e to the 4t. plus 12t e to the 4t plus 48t squared e to the 4t divided by 2 plus 64t cubed e to the 4t divided by 6. Okay, so we'll write it one more time. Final answer, f of t e to the 4t 12t e to the 4t plus 24t squared e to the 4t plus 32 over 3 t cubed e to the 4t, and as luck would have it, that checks at the back of the book. Okay, so now we're going to do number 28. I have x double prime, 6x prime, 8x plus is equal to 2, and I have x of 0 is equal to x prime at 0, which are going to be 0, which is just lovely. I love it when they're 0. Laplace transform of the whole thing. S squared x of s minus 6 s x of x plus 8 x of x is going to be 2 over s. Okay, s squared minus 6x plus 8 x of s is equal to 2 over s. X of s, 2 divided by s, and it looks like s minus 4, s minus 2. Yes, it does. Okay, so I have a partial fraction to solve. A over s plus b over s minus 4 plus c over s minus 2. Okay, and I get that 2, the numerator, is going to have to be a s squared minus 6as plus 8a plus bs squared minus 2bs plus 6cs plus c s squared minus 4cs. Okay, so I'm all set. Now this is over the denominator, and this is over the denominator, but I'm not going to write that. Okay, I look at the s squared term, and what do I get? I get a plus b plus c is 0. I look at the s term, minus 6a minus 2b minus 4c is 0. I look at the unit term, 8a is equal to 2. So that means a has to equal minus 1/4. No, it doesn't. A is equal to 1/4. Make those zeros better. Okay, so I got 2 equations, 2 unknowns. I got b plus c is minus 1/4, and I've got minus 2b minus 4c is equal to 3 halves minus 3 halves plus 3 halves. 3 halves. Okay, so I'm going to use Cramer's rule, solve for b. B is equal to minus 1/4, 3/2, 1 minus 4, and I've got 1 minus 2, 1 minus 4 on the bottom. So I got minus 4 plus 2 minus 2 on the bottom. I've got a 1 minus 3 over 2. So I got 1/2 divided by minus 2, which is going to be 1/4. So B is 1/4. Well, if B is 1/4, then B is 1/4. So A is 1/4, B is 1/4, C has to be minus 1/2. C is equal to minus 1/2. Okay? So I've got x of s, is it x of x? Yeah, x of s is equal to 1/4 over s plus 1/4 over s minus 4 minus 1/2 over s plus 2. And we see that this guy's number 4, number 7, the inverse Laplace transform, x of t is going to equal to 1/4 plus 1/4 e to the 4t minus 1/2 e to the minus 2t. And as luck would have it, that checks in back of book 2. And that ends the first video for this section.